Everyone. So our project topic is generalized multi-objective reinforcement learning with envelope updates in URLLC-enabled vehicular networks. I'm Zhang Yan from York University. So there are so many existing challenges in our real life in the highway environment. First is that we need to find optimize the route for maximize the speed, and also we need to avoid collisions and reduce the lane change times. On the other hand, on the 5G and post 5G network, we have to worry about the handoff. We cannot drive so fast to create additional handovers. And also, we have to make sure that we need to reduce latency and interference and leverage AI to control to do resource allocation for that. So we incorporate with highway environment. So highway environments have is the basis of our studies, and we choose the upper left one for the highway environment in this study. So in our multi-band vehicular communication network, we have the two different base stations, like radio frequency RF base stations and terahertz base stations. And you can see the target vehicles need to connect with the fast base station with maximize the handover of their data rate, and also have to avoid collisions by lane changes and the lane changes. So there are so many interference management and the relative the velocity controls with surrounding vehicles. They're put in the states, on our further MORL study. So our contribution in this study will be like we introduce the MORL framework for vehicle network, including states, actions, and rewards, and we extend to the multi-objective side. So reward will be a vector. And the reward function and our MOMDP like incorporate with the prior knowledge at target network. So this is based on our RF terahertz and highway environment. So this is a VNet testbed on highway environment. So in this testbed, we are not only to optimize RF terahertz network, and also we can control the autonomous driving features on highways. So this is our proposed framework for MODQN, MODDQN for MODDQN envelope. So as you can see here is our conventional DQN, DDQN. So we have only one experience replay pool for here, right? And DDQN incorporate with the experience replay, So they have to do the mini batch on that. But in our MODDQN, we have another pool for sampling vector. So there are two separate pool. First, first sampling for the state art rewards and net states, and the other pool sampling from the preference from this pool. So they're putting to the neural network and do the homotopy optimization as well, and then get the 2D action. So in here is our proposed envelope MORL solutions. First, there are three state-of-the-art part, like I mentioned. The first thing is that the DT and D omega is for the two different pool. So we sampling and do the crossover sampling by the discrete HER. And also in here, we have the two loss functions first tackled with accuracy, and the second one tackled the smoothing. So in our generalized loss functions, it will focus on the accuracy first, and the second thing is focus on the smoothing. So it will be optimized the training performance and the training efficiency in the two different perspectives. So our training performance is this is our training. So you will see here is improve the transport efficiency, handover aware data rate communications, and reduce the collisions. It's be compared to the other benchmarks, and also in our evaluation performance is even better on the to improve transport efficiency on these four perspectives. And here, if you can see this one is parental frontier comparison, you will see our proposed algorithm MODDQ envelope push the boundary out. So it will optimize the both on the transportation and telecommunications on the both side. So this is our reference, and thank you for listening, and have a good day.